This is part 2 of a two-part series trying to understand if the data in a medical record is true. Part 1 reviewed some problems with past medical history data, and Part 2 will offer some very high-level solutions to help ascribe confidence to issues in the past medical record. These are just some proposed considerations. It's not meant to be a comprehensive nor prescriptive article on exactly how to do this. Although I do think that, as we'll see, there's 5 levels potentially, that levels 1 through 3 probably should be implemented into medical records pretty much immediately. Let's start with, though, the question, why is displaying the certainty or truth of information in medical records important? Well, the first is that having actual information which is true about a patient will improve both the quality and speed of care delivery. But the question is, how exactly would this improve care? Well, the first part is that the electronic medical record user interface would ideally show in the interface the level of confidence beside a fact in the medical record. For instance, beside an item in the past medical history or beside an active medication listed, there would be some sort of a way to associate a level of confidence beside that particular issue or beside that particular medication. If the confidence was low, the user interface would alert the clinician, and then they would improve the quality of that fact. Now, of course, I realize that ideally in the future, the medical records shouldn't be showing low quality data. It should only show high quality data, but eventually we'll get there. The benefit of displaying this confidence level beside each fact is it greatly improves the ability of a clinician to pick up a new chart, to know what is true in that chart, and therefore it would save all the time which they currently do now manually fact-checking the record. As we've talked about in the previous post, where when a clinician picks up a record, they have to essentially go through the process themselves of looking at items in the past medical history and then trying to correlate these against the primary source materials to actually prove the validity of the claims which are written in the record. So this makes it quicker, and this makes the care better. I want to look at now a hypothetical 5-level scale of increasing complexity to help ascribe levels of truthfulness to issues in the past medical history. As you move from level 1 to level 5, the system becomes more automated, and it relies more on aggregate data analysis techniques in machine learning at the higher levels, whereas the very early levels rely on reasonably straightforward, simple rules-based approaches that I think could be implemented with little difficulty. So we'll start at level 1, which is manual linkage. Now, manual linkage is a concept that I've been talking about for years related to past medical history and electronic medical records. And unfortunately, I've never seen a system do this well. Generally, what I've seen is that most systems either have free text boxes where people just write a list of all the issues in the past medical history, and then they may write or jot a few points down beside each issue that elaborates on that particular item. Or the more advanced medical records allows each specific item in the past medical history to be entered, and then there to be a corresponding free text box to add more detail. Now, of course, the user interface to manually enter these past medical history issues is atrocious in the medical records I've seen. The version control around this free text box is essentially useless, and there's a lot of very silly infrastructure which would allow a medical student to come in and overwrite what an experienced clinician had previously written about a particular past medical history issue. And none of these systems, from what I have seen, link the issue in the past medical history list to a primary level source material. And this is the key part of this concept. The way it should work is that when an item is added to the patient's past medical history, that particular item and issue should be, as much as possible, linked to primary source material that support the claim being made. This material should be viewable as a snippet or a summary, and then the user can also click on that particular source material to view the full documentation of the original piece. For instance, if chronic obstructive lung disease was listed as an issue, let's say that the gold standard for diagnosis is spirometry and pulmonary function tests. Therefore, the clinician should be able to link the issue of COPD in the past medical history directly to the patient's lung function test when it was first diagnosed. And ideally, as new lung function tests and spirometry are added, these should be able to easily link back to that particular past medical history issue. Now, furthermore, if all the data that is available to make this diagnosis is just a note, for instance, of patient's symptoms of shortness of breath and a cough, then if that's the level of evidence we have to make the diagnosis of COPD, then that note should be linked to the issue of COPD. So therefore, when another physician came along and they saw the patient as COPD, they could easily see the snippet summary of the data supporting this and see that the support for this diagnosis is not lung function tests, but it's just a patient's symptom. And similarly, if the level of evidence we had was a bit of hyperinflation on a chest x-ray or emphysema on a CT, let's just link and associate these with the diagnosis. So therefore, whenever future clinicians need to come along, the process of manually fact-checking with primary source documentation is a snap. And it's very easy. And therefore, each physician can assess the data and ascribe their own level of confidence in whether that diagnosis is actually true or not, and if they have a high or low probability level of strength in the evidence. This is not a radical new idea, okay? Lawrence Weeds has been describing this as part of his problem-oriented medical record ever since the 1970s. And in particular, he has advocated, more than 50 years ago, Larry Weeds, not Lawrence. He's advocated, over 50 or 60 years ago, that on the very front page of the medical record, there should be a list of the patient's past medical history and of the active issues. And this list needs to be kept updated. And then, in theory, after this list, you could have an index which has all the primary source documentation. And so even if you had a patient which had only a paper medical record, you could still create a very easy way to associate issues in the past medical history with the original source documentation. And I tried to actually do this once when I was on ICU with very complicated patients that I was looking after for several weeks in a paper-based system, and it worked. And another quick example, if the patient had a left cerebral ischemic stroke in 2013, let's link to the CT brain report. And let's also link to the documentation of that admission. And if we also write under their past history that they have no residual deficits at 6 months and they made a full recovery, let's link to that physiotherapy note which indicated so. Now, as much as I advocate and love the concept of manual linkage, mostly because it's so easy to implement into electronic health records, that there's really no barriers or downsides to it, there actually are a lot of problems with this concept of manual linkage. It's a very imperfect system when trying to create a way to actually ascribe truthfulness to data in medical records. Because within manual linkage, we have to remember that the person who's actually ascribing whether something is true or not is a particular clinician, which is looking at this chart when they come in with manual linkage and looking at the source documentation and then assessing if they feel that it supports the claim. And by the claim, I mean the particular item in the past medical history well or not. So let's go through and actually list out 6 different problems here with manual linkage. The first is the process is manual, right? And so this means that we need to rely on the goodwill of the clinician who is documenting these past medical issues to actually link to source documents. Second is there's a variability in the accuracy of the items added to the past medical history. For instance, a medical student might think that a patient has venous stasis and enter that as an issue, when in fact that the main issue is that they have congestive heart failure. The third is that there's variability in what clinicians consider as appropriate linkage. For instance, each clinician will have a different understanding of what documents will support a particular claim. If the patient comes in through a medical ward, the clinician entering the patient may put the issue 6 seizures of unknown etiology in 2016. And they may link this to an EEG report. But if that patient was actually admitted by the neurology service, they may link the issue of 6 seizures of unknown etiology in 2016 to several sets of spinal fluid, multiple brain scans, various blood samples of tests no one has ever heard of, genetic and autoimmune tests, and multiple consultant notes. And all this they feel is required to support the part of unknown etiology. The fourth issue with manual linkage is that the process is static in time and the data can become outdated. So if a patient's lung function test was linked at 65% their FEV1, unless someone actually goes in and links the patient's COPD issue to their most recent lung function test, which has a value of 35%, the past medical history will actually continue to be outdated and show that the FEV1 is 65%. In a similar vein, the items in the past medical history may no longer be correct. For instance, if the past medical history notes pneumonia September 2018, pneumonia October 2018, each of these may link to a chest x-ray with an infiltrate. However, if the patient is then diagnosed in November 2018 with lung cancer, someone would have to go back manually and essentially erase the 2 diagnoses of pneumonia September 2000 and October 2018 and merge those into supporting evidence of the diagnosis of lung cancer, because those were actually probably misdiagnosis and the patient's infiltrates were lung cancer. And therefore, the chest x-ray from September 2019 needs to be linked to the lung cancer diagnosis. And so as you see, this requires a fair bit of fiddling with the old medical record, which is time-consuming and not reliable that people will do. And the last and the sixth problem with these techniques is that manual linkage is manual, and therefore it is generally prospective. It does not auto-link all of the issues in a patient's past old chart. This is time-consuming and not useful from the concept of a data mining perspective. I want to discuss one other problem with manual linkage, which is the concept of an Eruv Omission. In order for us to be ascribing a certainty to items in a patient's chart, using manual linkage, we're only essentially giving certainty to those issues which are listed. Quite often, though, medical records contain information about past surgeries, procedures, conditions, tests, treatments that, unless they're actually linked to an issue in the past medical history, no one may know about. And so we enter into this problem of errors of admission, where if no one's asked a patient if they have a particular condition, and if no one's gone back to the old records to verify if that has ever been documented or not, we may end up in a case where clinicians think that a patient doesn't have something, when in fact they do. But that data was just never linked to a created issue. And as I mentioned, finally, the big problem with this manual linkage is that we still can't validate a data's truthfulness in an automated way in the computer, because it's the clinician which is looking at the issue in the past medical history and comparing it to the supporting data and making their own assessment on whether that data supports the claim or not. We'll move up now into level 2. Level 2 uses something called guided linkage. In this case, when you enter an issue into the past medical history, the system prompts for what would be the typical documents which one would link to this. And if those documents exist in the system, it would then essentially ask the clinician to auto-link those documents to the issue. And if those documents were not present in the system, it would note their absence. Very simple example, you enter COPD, the system would automatically ask you if you want to tag and associate the patient's 5 past pulmonary function tests to that issue. And so in this way, the system guides you through the linkage. You could use a very basic rules-based set of associations. Although there are, tens of thousands of items in the ICD-10 code, I think that if you sat down half a dozen or a dozen bright internists over a weekend retreat, you could probably come up with linkage patterns for over 80% of the most common cases seen inside of a medical internal medicine practice. And so that's level 2. We're using guided linkage. We'll move up now into level 3, which really takes the concept of guided linkage, but expands it into other types of documentation. For instance, medications, associated clinicians, labs, tests, imaging notes, and supporting documentation, refuting documentation. And if you try to link all of these various discrete types of data to items in a past medical history list, you could easily see how even if you were using a snippet view, that it would become very complicated and busy, the interface. And so level 3 talks about one of my favorite ideas, which are data capsules, which are essentially a self-contained unit to hold all the important information which is relevant to a medical issue. And so, the COPD data capsule would include things such as the chest x-rays, the relevant COPD meds, the relevant COPD clinicians, the pulmonary function tests, all the clinical notes related specifically to COPD, and it would all be brought together into one single interface, which is really easy to navigate. And so this capsule first makes it easy to see all this data in the same place. It second creates an automated way to pull and import data that it thinks is important. For instance, the COPD capsule may automatically ask the user if it can pull in the patient's chest x-rays into this capsule because it believes those might be useful for the data within the capsule, even if those chest x-rays were done for another purpose, such as a pneumonia. And as I said previously, I think that even the idea of data capsules could be created using reasonably straightforward rules-based approach. If you start with the most common issues, again, you could probably take a small team of internists and build out the required rules over a weekend retreat. We'll move on to the 4th level now, which is automated linkage and automated data capsules. In this case, that linkage pattern between issues entered into the medical history and the associated documents, or between an issue and the associated data capsule, the actual data brought into those linkage or data capsules happens in a completely automated process. Whereas in the previous step, in level 3, the physician would have to confirm that they want to associate the data with the issue. The other big part of level 4 is that the system can, in theory, retrospectively look through information and try to link it together, or look through information in real time and try to link it together. And if it finds a link and a pattern that matches, it could propose to the clinician that that patient perhaps has a particular diagnosis. And the key part of level 4 is that the clinician then needs to accept the proposed diagnosis, and then, upon accepting it, it can be entered into the patient's past medical history. This is different than level 5, which we move into now, which is automated diagnosis and automated data validation. This is the highest level of data verification and would require much more sophisticated techniques than the rule-based issue linkage and data capsules we were talking about before. Ideally, this would consider multiple variables and factors in a patient's chart to ascribe a diagnosis and a corresponding level of certainty to this diagnosis. We discussed in the previous in part 1, all the considerations that might be required in understanding different types of evidence and the corresponding sensitivities, specificities, and quality of those sources of evidence, for instance, for hypertension or diabetes or HIV. And in level 5, the system would understand this, would be able to process this information in real time, as well as process historical data, and it would ultimately ensure that the medical record is always up to date, that the issues list is always current and accurate. And I actually suspect that this tool, this processing power, would be an integration you could add into your electronic medical record. And it might be sold by different vendors and different research groups, and you might pay for multiple different tools and products which do this type of data aggregation and diagnosis and validation. And it ultimately needs to just be a plug-and-play part which you add to the medical record. Perhaps it could be part of the FHIR clinical reasoning resources. Maybe that's how it plugs and plays in. But this is kind of the aspirational dream of where we want these systems to go. And ultimately, in this case, if a physician feels that a piece of information needs to be added to the automated diagnosis, or if the automated diagnosis is incorrect, the physician makes a suggestion to the computer, and then that suggestion may need to be validated actually by another physician, an expert physician, to ensure that the suggestion is correct. And then that suggestion helps update the training data sets. So how would you visualize this level of truth associated with data in the medical record if we actually could implement any of these levels? Well, I'm not entirely certain at this time of what the optimal strategy is. My suspicion is that medical records should start to flag information that they believe is incorrect. If you make a mistake by over-flagging information, it's not that big a deal. From a legal perspective in particular, it would be much better to make the mistake on flagging information which you think is which is incorrect, when in fact the information is correct, rather than the converse, which is to sell systems which flag information which only has high levels of certainty. I think going forward, you would then probably want information which is which is of an average level of certainty to be in some neutral style, and then information which is of a very high level of certainty to have some sort of a verified stamp or unique style associated with it. And as I mentioned, as clinicians interact with this user interface, as they correct information which they think the computer has mischaracterized, the system can learn from these mistakes and ultimately improve. There we have it. We've discussed now over 2 posts this issue of trying to understand how medical records can better display to the physician the quality of a particular piece of data that you're looking at on screen. And the big reason that this is going to be helpful is that it prevents the physician from having to go back and manually find all the source material for that particular issue, and 2, it ultimately will allow us to have much more robust training data sets and use data sets as we move into using more and more algorithms and machine learning with the electronic healthcare record. If you enjoyed this post, you may also like 2 other ones which are part of this series. One is called 5 Ways to Improve Required Fields in the EHR, and that one really talks about how fake data can perpetuate itself through required fields. And the second is how to manage auto-populated EHR data fields separately, looking at issues around data validity when we auto-populate and carry forward medical record data. Thank you for your interest.